Hello, everyone. This is Redgate Streamed, and my name is Rangel. I'm Redgate Solutions Engineer, and on this video, I'm going to approach the first part of a two-part series where I'm going to talk about database DevOps, compliant database DevOps, and how to practically introduce that into your environment. Not a um, subjective or theoretical approach, an actual practical approach to how to do it using Redgate solutions. So here we are. Feel free to hit me on LinkedIn. Always keen to expand the network. But without further ado, like I said before, this is the part one of that conversation. For that, I created two scenarios for us. On the first scenario, so actually it's one scenario, but broken down into two parts. The first part, we're gonna address the compliance aspect and also how to actually get the right foot on that door. So how do we start our development life cycle in a way that is gonna set us up for success. So those two boxes that we have, those first two items, we are talking about wanting to remove a shared database development model, and also wanting to remove obstacles around refreshing non-product environments taking way too long, using huge amount of disk spaces and exposing sensitive data. So there's those two cases, they are quite common. They are very fairly common, and they exist due to the fact that databases, unlike applications, databases are very large, they carry state, and because they are very large, it takes a long time to actually restore the database, to actually provision the database. So that operation alone is lengthy, so we can't just spin up databases to our heart's content on demand as we needed. We usually would run out of, come across limitations around infrastructure requirements, but also we don't want to multiply those that sensitivity that we have in production outside production, which are very likely, most likely, a less secure environment. So let's have a look at how we're going to address those particular cases. So I want to do so by kind of breaking that first part of the demo into three sections. So the first section is, all right, so we have sensitivity on our database, but where is it? So what specifically do I need to be worried about? Where is my sensitivity? What level of sensitivity? Is that bound to this regulation or that regulation? How do I classify that? How do I catalog that? It's becoming more and more pressing. And that's obviously going to drive the actual masking activity, the actual masking process. So let's have a look at how we would do that. So what we're seeing in front of us is Sql Data Catalog. Sql Data Catalog is a, once you have that implemented in your environment, it's going to be a web interface that will actually invite the business to participate in this activity. I personally don't believe it's fair to for the business to kind of put on the DBA's shoulder, which is kind of what we see mostly, the responsibility of identifying, classifying, and masking the database accordingly, so the business becomes compliant. This is an exercise that it's first not a one-off exercise. This is a continuous process, and also we have different owners to that data, and we need to make sure that we are tackling that appropriately. So, and we can do that via Sql Data Catalog. So one of the areas where the product is very, very strong, it's around the ease of use and the flexibility around its taxonomy. So we can, if we haven't delivered out of the box a specific category or a specific tag you want to label your data on, it's very easy to do so by creating new categories and or creating new tags. For example, I added the CPS 234 here, which in Australia, it's a cataloging data
for financial institutions, it's a mandate. So we must be doing the exercise that I'm going to demonstrate in the next few minutes. So here I am on the landing page, and I can see all of the servers where I have databases in it, and I can move into the instance, in this case, that I would like to further my classification. So here I can see that on this instance, I have done some classification, but it's very minute in terms of the overall population of columns and data. So if I click on that, I'm going to go deeper, and now I'm going to see all the databases in that instance. And I can see that for our example, my Redgate Streamed 1 prod database have had some classification done, which is great. When I click on that, I will then see the actual schema structure for that database. I'm not going to go through the process of classifying every bit of information, 100% of the data in there, although it wouldn't take that long when we use Sql Data Catalog, because we have the ability to do bulk operations. An example would be I can simply filter the databases that are primary keys and haven't had any tags applied to yet. So I can come over here and say, yep, select all, let's classify that. So the sensitivity is not sensitive at all. And the classification scope in this example would be out of scope. It's a system type of information. So if I wanted to get any other information, I could. If I want to define owners for that particular information, I could as well. I'll choose to apply this now. And another way that we can use our bulk classification is, for example, if I know that on my customer table I have information that are sensitive, I can come over here and start to classify that accordingly. So really easy, really, it's a really nice interface to do bulk operations that aim to maximize or minimize the time it would take to perform such activity, which I have had the displeasure of having to do it back when I was a DBA, and it was really like this big bang approach where you classify column by column, and it's kind of it sits there once after you finish, which is far from one of our situations. So I could go on and carry that out, but I'm going to move on to the next part of our demonstration, which will be the actual anonymization. So if I go here into my desktop, I've created this, it's called a masking set. So I have which is the output of what Sql Data Masker will produce. So Sql Data Masker will allow us to create masking sets. And within that masking set, so what a masking set is nothing but a visual representation of a set of rules we want to apply on a specific order, that once I execute that, it will be responsible for making that anonymization, that de-identification of the data in a way that it's ready for development, it's ready for tests, it's ready for any sort of training. The list goes on. Sometimes you need to provide the database. You have a database from a third-party vendor and something goes on, they want to give some sort of support to it. It's not unusual for them to ask for a copy of the database, but I would cringe if I was in a situation where I would just give that database back to the vendor. So Sql Data Masker is a fantastic way, and we're seeing that being used from different angles and different use cases as well. So what we see here in front of us is a set of rules that I've created. As you can see, I'm tackling the customer table as well as the customer notes table, and there is a number of things that I'm doing here. So and I'm going to go into a little bit more detail about that in a second. I thought that would be useful to show how that schema and how that data actually looks like underneath. So just gonna bring up those two tables, and we'll be able to see that just like you probably have on your own sets of databases, I have my own sets of PII, personally identifiable information here. So I have first name and last names, we have addresses, we have email addresses, we have credit card numbers, we have a denormalization taking place. So first names on two different tables. So if I'm synchronizing one, I need to make sure that the second one is also being masked. And also I have a open text field here that I told our support people to not put sensitive information there, but nevertheless, there they are. On the denormalization piece, even if you have a system that looks at multiple databases and then you have denormalization happening at a cross database level, we can very easily address that as well. So going back into Data Masker, let's explore some of those rules. So I'm gonna open up this first one and, oopsie, and let's have a look. So I'm just gonna open up so I can show you exactly what we have here. So I have my schema here in Sql Data Masker, and I have a rule that's addressing a number of columns there. One that it's not, it's the telephone number. So I left it out intentionally just so we can show that how easy it is to have a new UI that allow us to interact with that masking activity. So I can come over here and select my telephone number, or I could have just clicked on the telephone number on the left pane, and all I'm left to do is to choose out of the list of data sets that comes out of the box, which one is most relevant to me. So in my case, I'm gonna use Australian telephone numbers. Mobile numbers in Australia starts with 04. So let's assume I don't want, I'm only want landlines, I would go something like this, or the other way around, I could remove everything and leave just 04. And you have that level of granularity across all different data sets. I want to just bring our attention as well to this one. I can see we're using the same data sets, but for different fields. We call that correlated data sets, and they are specifically useful when we're trying to maintain a demographics of some sorts for the data. So addresses are a perfect example for that. So I am in one field setting one value of my data sets, and then for the second column, I'm choosing a different value. So let's pay attention as well that for the first name, I'm using only male names, and I'm addressing that. Oops, no, I want to update the substitution rule. Thank you. And I'm addressing that on my second rule, where I am coming back here and say, look, now I want to use female name data sets where my customer gender column equals F, equals females. So just to illustrate how flexible it is for us to really, as an outcome of this activity, have a very realistic data set. So I'm synchronizing values across to make up my email address. For example, Anderson.Rangel@Redgate would look like something after I mask my first name and last name to, let's say, John Smith. I want to make sure that my email address, it's now John Smith at something random. Here I am addressing that denormalization, and here I am addressing that open text field. If there is interest to know, hey, Anderson, you're just going too high level here. I am. I'm short of time, and if you want to know more about it, please feel free to reach out. We can run that in multiple working threads, which make this operation really, really nice in performance. So actually, I'm going to run that in my shared development database. So when I move in here, if I run, so I created the shared environment by simply restoring a backup of production. So if I run the same query, let's lock our eyes in Donalda here. She lives in Delaware. She's going to move to Australia now. She has an email address that is kind of relevant to her name, and also her credit card number ends with 9176. And let's see how that's going to look like now. So she's now Josiane. She doesn't live in Delaware anymore. Her email address, again, reflects her newly masked name, and her credit card number has changed as well. The denormalization has been successfully implemented, and I have masked that open text type of things. That's very generic. Type of information. So sensitivity in open text have been addressed as part of this exercise. So cool. So just a quick recap what we've seen so far. So we didn't know what we needed to classify. Data masker, Sql Data Catalog will help us with that. We can obviously, because our tools integrate, we can import those plans from Sql Data Catalog, so I know exactly what are the fields that are sensitive, and then I can run a report to make sure that the rules that I have in place are addressing the columns that I have classified as sensitive. So that's kind of well-rounded process. But if you're thinking, yeah, but that's quite manual, and you're not wrong. So that was a very manual approach. We have most definitely most sophisticated ways to ensure that as databases are provisioned, there are provisions already masked. And that's kind of the next part of this short demonstration. So I am gonna invite Sql Clone into the picture. So we have Sql Clone is our data virtualization solution. So what it does, again, from a very high level, and I am always more than happy to explain how it works in detail under the hood, but I will remain high level for obvious reasons. And Sql Clone it's our virtualized database. So it's what allows us to, let's say I have a 1 terabyte database, or let's use 1 terabyte for easiness of example. I can now provision those copies of these databases, but instead of using 1 terabyte, I'm now only need 50 megabytes. And instead of needing however how many hours it would take to restore a 1 terabyte database, I can do that in seconds now, and without exposing that sensitivity. So what we'll see is a immense, unbelievable, almost like unseen level of agility towards how do we provision those databases in a way that it's not a constraint to our infrastructure, it's not a constraint in terms of handover and time for operation, and also it's not a constraint in terms of becoming out of compliance with regulations that rules our development processes. So here I am. In order to create a clone, I first need to have an image. So let's do that. I'll create an image, and the image is made out of a backup file or by pointing directly to a live database. Our recommendation is we're already making backups, so let's use that as part of your process. I get asked quite a lot about best practice around creating images, and usually that will tie in with your existing sprint cycle. So if your sprint cycle is a fortnight or 2 weeks, then we want to create images in preparation for that new sprint. So as your backup is done and you are at that point in time, you create a new image that will be ready for consumption. So over here, actually, it's not that. It's the Redgate Streamed .backup. I think that's correct. Let's hope it is. It is. So here, Sql Clone, again, is that third part of the step is aware that there is classification carried in that database, and is letting me know that I need to apply that classification or that masking process or the modification process, more accurately, that will ensure that we are protecting that, that we are adhering to that classification. So I'll choose my masking sets. I could also choose things like, for example, any T-SQL scripts you feel like you need to apply. In my case here, my developers don't have access to production. I hope yours don't either, at least not DB owner access. And I want them to have exactly that. I want them to be DB owners on the clones that I'm going to provision for them. And I don't want to have to do anything post operation. So I'm going to carry on with that. All I have to do now is select where I want to store it, and I want to give that a name. So let's call it Redgate Streamed image. I'm going to create that image. And while that is, that image already exists, so let's create image 2. So once that's kicking along, I just want to say that because everything that you're seeing now can be done via API, that will always be my advice, especially when it comes to creating your images. It's an operation that it won't take the 3 seconds that it took to create. So if the databases are large, that process will be longer. And that's why we want to automate those processes, especially if we're applying masking on top of that, which will, again, depending on how much volume of data and the nature of the data that you have and how much needs to be masked, that will also add a portion of time. And again, more and more reasons for us to automate this process. So we, instead of becoming a hindrance, it's a positive scenario that we find ourselves in. So now I'm ready to actually create my image. So I have a Redgate Streamed image 2 that I just created. I am going to, if I wanted to, I could have an option to further modify, granularly modify the clones from a clone level perspective. That's not the case for us now. I'm going to say where I want to deploy that clone. I'm going to give that clone a name. So Redgate Streamed demo, and I am going to create that clone, which will take a few seconds to do so. One thing that I'm asked all the time is, let's go into that image, into that clone. Yes, it's 50 megabytes in size, but you're like, come on, Anderson, your database is 100 megabytes. It's the world's smallest database, and restoring that database would probably take the same amount of time. Yes, so I don't want you to just take my word for it. I obviously want you to go and try this for yourself. It's free trials, full capability, so couldn't encourage you more to do so. But now I have an image of a 500 gig database, and I'm going to do the very same thing. I'm going to come over here and I'm going to create a database, a clone out of that image, and we'll be able to see that we will only take those same 4 or 5 seconds to create. But now when I get in there, I have the same 50 megabytes in size. So, and the time was the same as well. So if your database is, the biggest scenario that I've seen was a client that had a 40 terabyte database that he wanted to implement this on, and they revolutionized their workflow. That's quite an extreme environment. The limit is 64 terabytes. But imagine if you have a 100 gig database, but you need to spin up that database in multiple locations and multiple times. So being able to do that on the fly, it's where the gold is from my eyes. So if I refresh my database over here, I have now this Redgate Streamed database. So let's have a look at how that looks like. And that looks, we don't have Donalda there. And let's just do something really silly. So let's imagine I am on a shared environment like we said at the beginning. And I come over here and I don't know, drop a table. So I'm gonna drop a whole table, and if this is a shared environment and I've done something out of a mistake like this simulation is, but sometimes you, in order to validate your work, you might want to run a proc or a trigger or anything really. You're trying a new index, and that will kind of disrupt the environment in a sense. But you don't want to not do that work so you don't disrupt the environment. So working in isolation, that's one of the many things that you're gonna start to improve the quality of your work. You're gonna start to really enhance your capabilities there. So if I go back into Sql Clone, I now have the ability, not the AdventureWorks one, my Redgate Streamed one. I can come over here, simply reset that database, which will do precisely that. We'll drop the database and it will recreate the database. If I jump back in here, so I dropped the customer notes table. So if I refresh that, I should have my customer notes back. So I kind of have an idea. So I use, because a segue question that comes along very often is around, all right, but if I'm making changes and I need to reset my clone, will I lose everything? And I want us to kind of park that idea for a bit, because a better process is what's going to ensure that we don't lose that. So I'm going to run this script, which is a very, very simple script. And if I can write PowerShell code, anyone can. So over here, I'm creating an image, and I am out of the latest backup that I have, I'm applying a masking set to it. So this is all variable setting, and here is actually the script that's gonna create the image. And now I'm actually creating a set of clones from it. I'm creating clones per developer, which used to be predominant drive. So each developer would have their own databases, but now I can very confidently say that it's more each feature, each development work item will have its own database. Or maybe you want to have a database per version, because why not? We can now, it's only 50 megabytes. Or maybe you want to create your QA environment on the fly. Every time you deploying, you drop the database and you create the database. So that's also very, very, very powerful. So I can see here that all of that has happened successfully. I can come into my databases, refresh that, and I should have a lot of databases now. And so I have it. So quick recap again. We classified, so let me bring back my screen. So that's me. That was the scenario. We did the demo, and now refreshing non-prod environment takes too long. Nope, no, it doesn't anymore. Uses huge amount of disk space. Nope, it's just 50 megabytes. And expose sensitive production data. No, it doesn't. It's all masked. So we can definitely check that box. And we want to move away from shared database development model, which we discussed is something that we created to overcome the challenges that the first set of criteria imposes on us. And we want to move away from that. Yep, we most definitely did. So that's kind of it for us now. So next part of the demonstration will be, how do we take it from here? How do we carry on with our development work? So thank you very much for listening, and I hope that has been informative, and I will see you soon. Bye.